So now we're covering how to do the characteristics for lab 11400. We'll go systematically by balloons. So we have balloon number 1 is going to be an angle between the right side surface and the right side of the angled slot. For this, you would think that that would be under size and angle, but unfortunately, size and angle is going to default to your base alignment, your standard alignment. The nice thing about it is, if you do it that way, it gives you inclination angle versus rotation angle. The idea with those is, if you have an angled line, let me give you an example here. If you had a line from here over to here, that is at an angle, whether it's viewed from the top view. So if we go view from plus Z, you see that we have an angle. Well, we could be measuring the angle from this line down here up to this line here. We could also be measuring the angle from this line here over to that same line the other way. We could also be measuring the angle as viewed from the front, which would be minus Y. See that we have an angle from our primary datum down to here. So that would be maybe 45 degrees or so, or 40 degrees in this case. Or we could be doing the supplement or the complement of that angle. So yet again, we could be doing view from minus X. And yet again, we have an angle from here down to here, which would be different than the other two I just mentioned. And that's where angles get a little bit tricky. So you could do size, angle, and sometimes projection angle 1, projection angle 2, inclination angle, or rotation angle may work for what you want. Just know that those all tie back to the base alignment. The way that these features are dimensioned, yes, number 6 right here comes from the base alignment, but number 1 doesn't come from the base alignment. It comes from an edge of the part. So none of these size angles are going to work out for us. Turns out, under form and location, it's hidden all the way down here. We have angle between features. And this is going to be your general purpose, easy output whenever you don't have a direct angle characteristic. And by direct characteristic, I mean something that comes right off the base alignment. So we'll hit angle between features. I'm going to double click on that. And for feature 1, I am going to, this is going to get a little tricky because we can't really see these off of our model here. And then you go to rotate the model and it doesn't let you. What you can do instead is either go to wireframe and turn off show CAD models, or you can turn on only display, what is this one called? Show only selected geometric features. That may be an easier way of doing this. We are looking to do a plane on the right side of the part, and you know, this view is not great either because it's showing you each feature by itself with no CAD model. Let's try going show all geometric features. That might be a better setting. We'll go to feature 1 now, and it looks like the plane that we want is plane number 4. So we'll click on that and say OK. For feature number 2, we're going to want this plane 5 over here. And say OK. That should give you a nominal that's pretty close to whatever it says on the print. Print says 10 degrees. I like it. I'm going to worry about correcting upper and lower tolerances after the fact. Our next balloon is the distance in between this edge here and the center of that circle. Well, that does not fall along X, it does not fall along Y, so this is actually going to be a constructed feature as well. This one I probably should have done in the last video, but it's going to be under the construction and perpendicular tab. Who would have guessed? Perpendicular. So when we do a perpendicular, it's added to the list, but it starts off as white. We need to fill up what to do with that. We'll click on feature 1, and we have to do the circle first. I'm going to select circle 1 here and say OK. The reason we have to do it first is this will be perpendicular to whatever surface is second. So we'll click on feature 2, and our feature 2 will be plane 6 back here. So having your CAD model set to this setting is quite nice for this selection, especially when you're working with planes. Now we can add our tolerance automatically here by selecting depth. If you forget to do this, no worries. You can always come back in and do it later. Let's pretend I forgot. Okay, we have our perpendicular. However, there's no characteristic associated with it. I'll just come back into the Features tab, double-click, and we'll select depth for that. We'll say OK. And now in the Characteristics tab, it adds that perpendicular back in for you. Next, we have this 30-degree angle. Now that one does come directly off of our base alignment, so I want to show you two different ways of doing this, just so you know the tools that exist. Because this is right off the base alignment, so a lot of times what I'll do with this is I'll go size, angle, and I'll just run down the list. The ones that are helpful are projection angle 1, 2, inclination angle, rotation angle, and if you're doing like a cylinder, feature angle can be helpful. For planes, it's going to be projection angle 1, 2, or inclination angle, rotation angle. If we do projection angle 1, and we know we're looking at feature number 6, or plane number 6 rather, notice that that gives us an angle of 0.157, which is definitely not what we want. We'll go to size, angle, projection angle 2, and we will again grab plane number 6 and say OK, and that gives us minus 29 degrees. Well, we're looking for a positive 30 degrees, so technically this is giving us what we want, but it's showing it as a negative, which, I don't know. Some people wouldn't like that on a dimension report. I've seen it done this way. It does work. You also could go angle and inclination angle. Grab that same feature. Notice that this is giving us a nominal value of 89 degrees. That is obviously not what we want in this case. And the last one, size, angle, and rotation angle, and we'll grab the same one, plane number 6. That one is giving us 120 degrees, definitely not what we want either. So those four methods can be helpful in some cases. I'll show you a different method that I like to use that works pretty much every time. You would think it'd be under size and angle, but if you look under form and location all the way at the bottom, they have angle between features that is hidden. So if we double click on that, and then for feature 1, we'll grab plane number 6 and say OK. For feature 2, we'll grab plane number 2. And plane number 2 is our primary datum on the front of the part. We'll say OK. And what I really like about this is it allows you to do the supplement, complement, or inverse. Notice that it's kind of doing exactly what I want here. It's smart enough to pick up the angle that I'm looking for is around 30 degrees. But I could also invert it to 180 minus the initial. Or I could do, what would that be, 180 plus, is it? Whatever it shows in the graphic. And then over here we have another option as well. So basically you'll add or subtract 90 or 180, which can be helpful if it's not giving you what you want. That one pretty much always works. The issue with the others, the size, angle, and picking from one of these four options here, the reason that those exist is if you're looking at the angle from the top, you're seeing a different angle than if you're looking from the front versus if you're looking from the left side, right? So in each case, let's say we take 2D line 1 right here, which I just drew as a sample. If we look at the angle of that line from the top view, that looks like, I don't know, somewhere around a 45 degree line going negative. If we look at it from the front, that looks like maybe a 45 degree line going positive. And then if we look at it from the left side, that looks like maybe a 30 degree angle going positive. So that's what's going on with these different settings right here. It's very likely you'll end up using the form and location, angle between features for just about everything you do. All right, back to our originally scheduled programming. We are picking up with, we did balloon number 3. Now we're going to pick up with balloon number 4. Now balloon number 4 is the distance from center to center. We have to use a polar caliper distance because we're not going straight along the x, and we're not going straight along the y. If we were going distance from here to here, that would be regular caliper distance. If it was distance from here up to here, that would also be regular caliper distance. This would be y, that would be x, of course. When we do polar, we're taking the shortest path on an angle from hole to hole. So we'll go size size distance. We are going to do a polar caliper distance. Double click on that. For selection, we'll go between circle number 2 and OK. Click on the second tab, circle 3, and OK. We have the option of going minimum, maximum, or center. Minimum would go inside radius to inside radius. Center goes center to center. And then maximum would go outside radius to outside radius. CAD entities is a good default here. That's going to take, if you had features that are not formed correctly, like they're a little out of round, this will use whatever the theoretical is, whereas this will use the actual measuring points. CAD entities is the default you want. This asks you to select a primary datum. This is as if you're setting dial calipers on a surface. You would want to set them on this top flat surface to get an even measurement from here to here. So for our primary datum, we'll select plane number 1 and OK. 1 inch 787, and it looks like I did something wrong. I went maximum to maximum. I got to switch that to center. So I was just comparing this actual down here to the nominal on the blueprint, which I'm looking at on my other screen. And if you get a value that's too far off, yeah, you probably did something wrong. All right, so that's looking good. Now we have balloon number 5, and you would think balloon number 5, you could do a caliper distance from here, or a polar caliper distance from here to here, but that actually will not work because that will give you from centroid to centroid. So if I had probed that feature, turn some of this off, turn my shading back on. All right. If I had probed 1, 2, 3 points over here to 1, 2, 3 points over here, a polar caliper distance would go from the centroid of one feature to the centroid of the other, and it would give me some weird diagonal line. That's not what I want. In this case, I actually have to do a perpendicular. I am going to select the centroid of one measured feature, and I'm essentially going to shoot an arrow over to the other side, perpendicular to that surface, and whatever thing it hits first, the length of that line is what we'll measure. So that's what perpendicular means. This is a constructed feature, so we'll go construction perpendicular. I have to switch back over to the features tab to see where that perpendicular came in, so this one's a little strange. And also, I'll go back to my only display. Let's see, what do I want? I want wireframe, and I want shading off, and I want to only display these features. So the settings are wireframe and show all geometric features. We'll double click on perpendicular. Feature number 1 here is going to be, the order here is important. The one that you're perpendicular to is the second selection. So in this particular application, there's nothing that shows you whether this surface is more important than that one, but in the case of measuring from this circle to here, you did actually have to select the circle first and the plane or line second, because the plane or line is defining the perpendicular direction to shoot that arrow, so to speak. Over here, if we select this surface first and that one second, the arrow will be shot from the second surface to the first. If we did the reverse, we selected this first and that second, the arrow would be shot from here over to meet there. So in applications where the angle between this and this may change, just be careful about the order you selected in. Okay, so we want, let's scroll down through the list. We want plane number, let's say we want plane 7 on the left side to be the first selection. And for feature 2, we'll grab plane number 5. So we're coming perpendicular from here to whatever we hit there. We'll say OK, and we'll output our depth here. That's what we care about. I'm seeing our nominals coming in at 472, which is good because that's what our blueprint says. Next, we have balloon number 6. So technically, this one could be output as a direct characteristic as well. You could use size, angle, and 1 of 1, 2, 3, 4. An alternative way of doing it would be to come over to one of our 3D lines. This would be the one that we want. We could double click on the 3D line, and here we have A1 and A2. This is your change in y over x and your change in z over x. So y divided by x would be asking you, how much has our y-axis position changed as we move our x along, which would be view from top, basically. And our view of z over x would essentially be looking from our front plane. You can see we have a very shallow angle there. So I would call this like the poor person's angle output. But in this case, it does work because it comes directly from our base alignment. Right? We could check this right on and say OK. But just to show you my new favorite way, form and location, angle between features, we could accomplish exactly the same thing by selecting feature number 1 as our, as our 3D line that we wanted, and feature number 2 as our plane number 2. And notice that that gives us that exact same 7.4. So this trick works pretty much every time. Notice that the graphic here has updated. It's looking at it at a funky angle, but you can invert these. You know, that's plus 90 degrees. That one's plus 180. That one's plus 90, whatever it is. This one's minus 90. That one's minus 180, and this one is plus 90. So just to have those options there, the angle between features tool really is nice. This nominal value is 7.49. You'll notice on the print that it's 7 degrees. That's just saying that when I rounded this to make it a one-place decimal on the CAD model, it truncated those extra 0.49 degrees. And I think this one is like almost half a degree off as well nominally. That's just because of rounding. I'll say OK here. We'll correct the nominals, tolerances, and balloon numbers later. All right, so balloon number 7 is this 83-degree angle. Now, we definitely could not use one of these direct characteristics tricks that I just taught you about. Here we have no choice but to use angle between features or rotate our base alignment. That's a whole different ball of wax. We'll go form and location, angle between features. Feature 1 will be 3D line number 1, and feature 2 will be 3D line number 2. Notice that comes in at 82.49 degrees or so. That's that half a degree off that was rounded. No worries on that. We'll correct our nominal and tolerances later. Last but not least, we have balloon number 8, which is this 40-degree angle. You could use this size angle pull down. In this case, you could also use direct characteristics off of what plane is that? Whatever plane number this is. You could do direct characteristics off of plane 8 here as well, but to keep things simple, we will again go form and location, angle between features, and the features that we'll select will be plane number 8. And for our second selection, we'll do our primary datum, which is plane 1. That gives us an angle of 140, so this time it did something that we didn't want. The nice thing about angle between features is we can just force that right here. We'll force it into that 40. Any of the other angle outputs don't have that nice option. Okay. Next, we'll come in and correct our nominals and tolerances. That's a matter of double-clicking, and this first one is our 9-degree angle. That is talking about balloon number 1, which should be 10 degrees. Looking at our title block here for angles, that's going to be plus or minus half a degree by default for any angle. So we just have to, our nominal is already set to 10. We have to correct that to plus or minus a half degree. One thing I always forget about angles, for whatever reason, it doesn't come in with a minus. We have to remember to put that minus on the lower tolerance. We'll name this feature feature number 1. Say OK. Then we'll come over to our perpendicular. Our perpendicular is balloon number 2. It should be 1 inch 028, 3-place decimal, plus or minus 5. So that's balloon 2. That's 1 inch 028, plus or minus 5. Then we have our angle between this back surface and here is 30 degrees, title block, plus or minus half a degree. So that's balloon 3. It's going to be 30 degrees, plus or minus half a degree. Then we have balloon 4. That's going to be our 1 inch 312, plus or minus 5, polar caliper distance. So balloon 4, 1 inch 312, plus or minus 5 thousandths. And OK. Balloon 5 is the 472. That was our perpendicular distance. That's also going to be plus or minus 5. Balloon 6 is our 7-degree angle. Right here. It's going to be plus or minus half a degree. Did I miss something? I certainly did miss something. Oh, I have duplicate dimensions here. I have an extra angle. I was doing that as an example. We'll get rid of that one. All right, this angle between features. This is balloon number 6. This is going to be that 7 degrees plus or minus half a degree. This is that one where the nominal is off a little bit. Balloon number 7 is going to be this 83 degrees plus or minus half a degree. Remember to put in that minus. And lastly, balloon number 8 is going to be this 40-degree angle right here. And that one is also plus or minus half a degree. Remember to put in that minus. So now it's a matter of running our dimension report. I've already run the program itself. I have not added any measured features here. So I should be able to come into my characteristics tab here, hit run. I'm not even going to clear my existing results. That'll lock me into clear current alignment. I'll do all characteristics and hit start. This will dump all of my numbers into my dimension report, and now I'll systematically verify that I've accounted for all my balloons and that all my nominals and tolerances are correct. If it doesn't show you your dimension report, you can go view and multiple report, and that will open it right back up. All right, so we have balloons 1, 2, 3, 4, 5, 6, 7, 8. That's good. And I'll spare you the time of checking this systematically on the video, but you go down the line next and you check to make sure your nominal value and your plus and your minus is correct for each one. You might also look at anything that's red or anything that's using up a large amount of the tolerance bands here, and that might mean that you picked up something wrong, or you're outputting in the wrong direction. For this lab, I do see that numbers 6 and 7 are quite far on the extremes. That's because of the rounding error when I created the blueprint. You go to a 1-place decimal, it just happened that it was about half a degree off. So this is all looking good. Thank you for watching. I'll see you at the next video.